So we're asked to find the particular solution. We're supposed to find y equals something so that would make this equation be true, especially when if you plug in x equals 1, you get out y equals 4 pi. So we'll deal with that in just a second. To solve this differential equation, it's separable. You've got dy dx here, in other words, right? So you can move dx to the other side. And then you can take the antiderivative of both sides. So the antiderivative of 1 with respect to y is just y. And the antiderivative over here, we can note that the derivative of tangent is secant squared. So the antiderivative of secant squared would be tangent, right? The antiderivative of something so that its derivative would turn back into this. So the derivative of tangent makes secant squared. We just have to watch out for the chain rule, because if we were to take a derivative of tangent pi x, an extra pi would come out. So let's try like this. Maybe we're wrong. But if a pi is supposed to come out, then we want to factor out 1 over pi, which would make this pi cancel out. Let's check it though. And then we need an arbitrary constant c because I evaluated an indefinite integral of both sides. Oops, this needs a pi. So if you take a derivative this side, the derivative for tangent pi x is 4 secant squared pi x. But then when you take a derivative of the innermost function, you get pi. So 4 pi secant squared pi x. That matches what we have up here. Okay, so that is the general solution. We need a particular solution. If we plug in 1 in for x, you should get out 4 pi in for y, is what that notation says. So replace y with 4 pi. Replace x with 1. And tangent pi, if you need to know what that is, tangent is sine over cosine. Sine are the y coordinates in the unit circle, and cosine are the x coordinates. And so if you rotate pi, which is 180 degrees, you're at negative 1 comma 0. So that means sine is 0, cosine is negative 1. So sine divided by cosine makes 0 in this case. And then that's a quick equation to solve. C is 4 pi, right? So your particular solution is when you found the arbitrary constant based on that initial value information. So there's our particular solution.